Hello, and welcome to part 2 of our series, where I test out different 3D rendering engines while trying to find a substitute for V-Ray, because V-Ray is currently my go-to rendering engine and I just want to see what's out there. So this is the second video of the series. If you haven't seen the first one, I suggest you do. I guess I can at least show you the results from the first video. So if I do this, there we go. This is V-Ray, right? So this is what I did in V-Ray. Whoop, let's move here. And this was something that I was trying to not necessarily replicate, but where I tried to get a similar feel for the scene in different other different rendering engines. So this one was Enscape. Let's move back here. This one was Enscape. This one was D5. And I believe, yeah, this one was Unreal Engine 5, right? So this is how much we managed to test last time. I still have quite a few engines to go through, and I have changed up a little bit in terms of what kind of scene we use. So I've tried to use a different model with the same, helmet design. And last time we used the lady, this time I decided to use a guy. So this is the model, and then just decided to add a little bit more to it. So just added a little bit of a drape, simulated it with kangaroo and grasshopper. And we can see the model right here in Rhino. Nothing fancy. 2 light sources, one from below, one from the side or from the back. Then, as per usual, we have 3 light sources right here. We have the cloth, we have a single mesh for the whole body, we have a single mesh for the helmet. Yeah, and I guess that is it. We need to decide what kind of software we're gonna start with. I guess it's gonna be Keyshot, right? Let's go for Keyshot. There we go. So Keyshot is loaded, and as you can see, this is a demo version. I assume it has the same functionality as a regular one. It's just that I don't want to pay for Keyshot without knowing how powerful it is first. So first thing is to figure out how to actually import the 3D model into Keyshot, which I guess is just file import, right? And we use helmet scene 2, we hit OK. Asks us for position, for scene. Okay, that's fine, that seems fine. Geometry, import NURBS data. Okay, great, so it understands NURBS, it's not just meshes. Okay, sure, let's just try importing it as, with these default options. And seems like everything has imported except for okay, so sub-D geometry doesn't work. That's a problem. So sub-D geometry is just understood as also my computer is just burning up. Is there a way of, yeah, let's pause the render for a bit. You can see here these quads, right? These large polygons. Same polygons can be observed here if I hit the tab button and use the non-smoothed version of my sub-D geometry. Same polygons can be observed. So my assumption is that it doesn't understand sub-D. That's fine. We will just use grasshopper to quickly switch from sub-D into a mesh. There we go. I've converted everything into a mesh and saved it as a separate file. In Keyshot, I will just go to File, New. We just straight up open up a new file, hit import. There we go. Now this bad boy is smooth. And my computer is going crazy again. I think that's the CPU usage. You can see here it's set to be 100%. I assume if we do like 13%, it's both the rendering slows down, but also the computer becomes much more quiet. I wonder if it's possible to do GPU. Oh, of course it is. There it is. There's the GPU. Yeah, this is much quicker. What's denoise? Will this work? Seems like it's working, huh? But there are no settings that I can change here in terms of denoising, so I'm going to have it disabled for a bit. Okay, cool. What's tools? unwrap UVs, flip normals. Oh, there's so much stuff here. There's material tools, mesh simplification. Okay, we are not dealing with those. And then we have light manager. And here, I assume it's only the environment light. Can we turn it off? Yes, we can. That's perfect. Okay, for now, let's leave it on because I don't know how to create new lights here. There's also importing a library. Oh, okay. So additional menus. Let's start with the materials. Human skin. That's always a tricky one. Translucent. Okay, sure. Let's go for it. I have no idea how translucent it is with this environment, so it's sure. For now, we will have it like that. Human skin. Great. There's a bunch of ugly ones here. There's black cloth. Weaving? What the hell is weaving? Is this normal? Doesn't seem like it's normal. Oh, okay, so this is some sort of a... This is not a material, this is much more like a script almost. Okay, cool. Doesn't work for me though. Oh, and it's downloading right here. Got it, that's cool. That's nice. Will you work though? Okay. Looks bad. Why does silk look bad? Anyway, let's stop messing around with it. Do we do copper? We do copper. Oh, brushed one has a nice... It's immediately the scaling is good, at least. That's cool. These will need to shine light as well as these. Is there a way? I still can't see. There's lighting here, but there's no lighting creation. Lighting, custom. No, so there's no lighting creation here as well. How do you create light? Can I... Okay, let me try selecting one of these balls. It's using the emissive light. What if we do area light instead? And I just bring it up. Oh, it does shine light. Okay. So I assume there's a way of... Yeah, models, for instance. Yeah, okay, so there is a way of how we can at least create primitives. Let's do disk. Blam. Translate, rotate, scale. Okay, what if we turn off translation and... Oh, the scaling was just super small. Okay. And then if we add the area light to it, it's black. Oh. I'm confused. I just hit OK here and maybe... I right-click the geometry just to see if there's... Okay, we can unlink the material and then it makes two of them. Which means that this one is probably going to be the bottom one? 1000. Yes, it is. And for some reason 10 lumens for this is fine, but 1000 lumens for this is still pretty low in brightness. Do we do watts then? Ooh, okay. So watts work. 40 watts. No, never mind. Move part. Oh, so you just right click and you choose to move part and then you can scale it. Okay, good. So I'm going to scale you to become very narrow. Very narrow. Even more narrow. Okay. And now you can be reflected. That's fine. Yeah, I think that's gonna work. Okay, so we have this, and this needs to be hidden. So visible to camera, no. Okay. The plane itself is not like it's a 5-watt power source, so it doesn't even retain the color, right? It's grayish. While if I turn this off, like you can see how much light it still produces. So this is bull. What if we do make it smaller? How the hell? Why does it become more intense when it's smaller? What do you mean? Anywho, that seems to work. So we continue. So what if the bottom light is just 1 watt, just like that, and it's warm. Well, that's very warm. Less warm. Something like that. And the little doodads here are also quite warm. Can that work? That can work. I think it can work. So that's one thing, the human skin. And the subsurface color, right now it's set to be pink. I think we can go a little bit towards orange, something like that. And then for roughness, we can have it a little bit rougher. But one thing that I really want to have is a bump map. And it does have a bump map. Interesting. Okay, so we keep it then. Oh, cool. It has a material graph as well. So the camera will need to be set up in the camera view according to the proportion of the view, of the set view, of course. So since this changes the proportion, now our camera placement is messed up, but that's okay, sure. We will fix that. We can just straight up use like drag and drop materials onto here. Come on. For instance, a fuzzy cloth. Ooh, I like the fuzz. I do like the fuzz. This is strong. This is really strong. Okay, presets, landscape. I want a 4K image. There's no 4K image, naturally. But what we can do is we can do 1920 by 1080. Why does my resolution not change? Hello? To 160. Okay, it doesn't change. I guess it's going to ask me again. Right now I'm just describing the proportion, and it's going to ask me again later. I think we are done. Now all we need to do is to render out the image. I guess the big render button is the thing that we want to use. 4K. Okay, so now it pauses this and starts a rendering process. Why? And here it is. So I basically just made a print screen from Keyshot and just saved it as a separate JPEG, just because, you know, we don't want to deal with watermarks. Quite an unpleasant end to the tests that we've made. All in all, I feel like the image itself looks pretty nice. It's just that, you know, we can't zoom into it because we don't have the resolution for it. Anyway, I'll finish up here with Keyshot, and we'll move on to the next program. Okay, so here we go. We have Twinmotion, our contestant number 2. I don't know how to call those, but either way. It's a free program, free for non-commercial use, to be exact, and it stands on top of Unreal Engine 4 and is tailored for renderings, mostly for architectural renderings, right? So it should be a simplified version of Unreal, that's how I see it. I have never used it before, so I don't know what to expect, but I guess let's just dig in. So the first thing that I want to do, well, I guess that little import button right there kind of tells the story, right? I want to import my file. So if I click here, it's going to give me like a direct link. And you can see that I've already kind of clicked on it, and I just wanted to see at least the first step if it's gonna work or not. I can create a direct link between my Rhino file and whatever this is, Twinmotion. And then collapse by, I don't understand what it means, collapse by material. I assume the geometry will be grouped by material. So basically we have our 3D model here, and we are creating a direct link to it through here. I click on import and nothing happens. Hello? I guess we need to do something here, right? Tools, toolbar layout. There is the Datasmith plugin that was installed, but it's unticked. So let's see here. If I tick mark this and hit OK, then there is the whole Datasmith kind of rollout. And let's see what happens if we click on synchronize here. Will we have anything? Oh, there it is. Okay, at least I figured out that one. Ooh, why does it look like that? We'll need to check that out. But at least this works. So it's called a direct link. So I assume if I just select the helmet and move it to the side. Okay, that didn't work. What if we refresh it? That doesn't work. But there is this auto sync button right here. So I assume if I click on that, it's going to constantly, yeah, now it's syncing. So my guess is that if I now move this up, okay, good. So we can have a direct link here. So then we have this little arrow here that expands, what does it expand? Materials, vegetation. Okay, so it has like a bunch of different things that you might want to add to the scene. Let's just quickly investigate that. Materials, metal. Oh, okay, so it's like just a metal library. I really hope that we will be able to change the metal appearance. Let's say slightly warm bronze. Yeah, drag and drop. As easy as that. So let's just add the materials while we're at it. So that's metal, then we do fabric, wool base. It's actually nice that we could use, but I'll use wax and I'll just add it to my... Okay, let's not use wax, let's use styrofoam and add it to the person, because or actually, YOLO, let's use wax, whatever. Now let's investigate how we can change the material. So for instance, for the wax, I want to change the color to be a little bit closer to white, of course, something like that. But is there anything? Oh, there's the more button. So there's texture, but it doesn't seem like it's using any texture, and opacity mask. I don't understand it. Generic, what if I clear it? Now it's empty. Okay, so there was something in there and I just cleared it. Whoops. Anyway, at least we can go back here and then play around more with translucency. Okay, so this is how translucent it is. Oh, this is very nice. Then we have reflection, either, I assume either matte, yes, or fully reflective. Weather, I have no idea what this means, so we just have it off. Oh, and you can't see it, but there's also settings here. Oh my god, there's more. So there's bump, so I assume we can add the bump to it. Will it understand the normal map? It does. It does understand the normal map. That's very nice. Let's have it full on and change the scale. So the scale also works great. For now, this emissive material, I can see it right here and it's being applied. And I think all we need to do is just find, yeah, there it is, glow. We can just, whoop, increase the glow. Okay, so that's done. Then for the metal, how does the metal look like? Looks like garbage. Do we change the scale of it? Nothing changes. Cool, 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 cool. Okay, back to Rhino. Let me select this little guy right here and let's create a texture map for it with a box map. Enter, enter, enter. So bounding box around it with locked size of 100, not 1000, sorry. 111 lock 100 mil repetition. So basically the texture will be repeated every 100 millimeters. Now if I look at this, you can see, hurrah, there is indeed now texture here, which means we can go back here and now we can mess around with the scale of it. I think that looks fine. A little bit scratched up. That's nice. So that was materials, vegetation. Let's just do a quick one. Trees. Do we just... Oh, you can just plant trees. How do they look like? Honestly, I'm gonna lie, this is pretty damn good. Like for a backdrop, these are really good. But we don't care about them right now. BIM information. Okay. Okay. Oh, you can't see it. God damn it. Sorry. So we can see the frames per second that we're dealing with. Oh, that's nice. That's nice. This didn't help. We still need to get rid of the light. So I'm going to see what's here. We have the import, we have the context, paths, vegetation paint, vegetation scatter, that's very good, and urban context. Then we have settings. Okay, settings are great. Let's see. Renderer, path tracer, what is this? Ooh. Okay, so path tracer is basically us changing between, you can see the frame rate drop. We are changing between purely GPU mode towards like the actual ray tracing of the light mode, which is nice. And then I can see that the denoiser is on, because once it finishes, it just blip, creates a denoised image. Okay. For now, I'll turn this off, and let's see other stuff. GI, so that's global illumination. Of course, it's on. More options. This is how far we're calculating the GI from. So I assume the shorter the distance, the better the quality is gonna be. So let's do distance 25 meters. Auto exposure, we turn that bit off. We never use auto exposure. We will always calibrate according to the camera, through the camera settings of the exposure. Much better control there. Then we have sun intensity. There we go. That is how you turn it off. You just have a daytime with 0 intensity for the sun. We're finally done going through this. So now let's go to lighting, or actually let's first create the lights and then turn off the global light. So let's do an area light in the bottom like that. Let me move it up. Okay, got it. So it was shining downwards, and this is how much it engulfs. So let's rotate it around 180. There we go. Move it up, something like that. Make it smaller. Let's say 2 meters by 2 meters, not 52, just 2. And then we have shadows. Of course, shadows should be on. Then let's do a neon light like that. Okay, now we can actually turn off the overall lighting. Sun intensity, whoop, tiny bit colder. Maybe not that warm though. A little bit like that. Okay. And I assume with path tracing, yep. With path tracing, it actually kind of will show the glow of the whatever you call it, forgot the name. SSS, subsurface scattering material. So for this one, we could use something from this angle, something like that. We are looking for a nice little angle. Yeah, I kind of want to do something like this. I kind of like it. Okay, let's see now. Settings, render. Here we can actually change the samples, right? So we had 512, if I remember correctly. We had 512. Then we have media. We're going to capture an image, create image, more. Oh, wait. So image. We already have an image here. And this is where we select what we're going to be exporting. So image 1. And then there's the start export. Okay. So here, I assume under image, under more, you work with the settings for that particular view. So format is very important. Output, custom, no, let's do 4K. Okay, that's good. It seems like it's clipping off the bottom now. So it does recognize the 4K resolution or 4K aspect ratio. And then we have the camera settings where we can change the field of view. Okay, sure. We do 45 if I remember correctly. Then there's vignetting. We changed all of these, but I will do depth of field though for this. And I'll choose the helmet so that this gets blurred out a bit. Export. Image, start export, render engine test, images to, yep, that's the folder. And I guess it's just gonna do its thing. Okay. And there it is. Well, it's not there. Actually, it's in this folder, one of these two. So this is the denoised version, and boom, 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 boom. I should be here. So this is the denoised version. As you can see, it's pretty nice. And we also have a low sample low sample non-denoised version, so it does have a little bit of sharpness there, and it's kind of nice, but I think the denoiser works in this case quite well. So it is what it is, right? This is what we have. I think with dialing in the numbers, we can get a pretty good result, like a pretty high quality result. So that's what we have, and still quite fast, to say the least, quite fast. I'm happy. Like, Twinmotion up until now is one of the most pleasant software packages or rendering engines that I have used, and most user-friendly. So I highly suggest checking that one out. I guess let's move on to the last one, which is going to be Blender. Right, so we're going to use Blender, and we're going to be using not just Blender. Actually, I should probably turn this off. No, I don't want to save. We're not just going to be using Blender, we're going to be using both render engines of Blender, meaning Eevee and Cycles. Or is it Cycles X? I don't know. I never know. So we're going to be using both of those. Keep in mind that I have used Blender before, and I have rendered out with Blender before. Nothing professional, nothing for a client, just for, personal fun. So I might not know everything about it, but I know a little bit, right? So my kind of experience in here is not going to be from the perspective of the first-time user, but rather from a perspective of a hobbyist, I guess. So first thing that we need to do is, as per usual, delete the default cube. And we will be importing some stuff. And here we don't really have a way of how to import Rhino file, so we'll need to import it as a OBJ. And for that, I actually need to export the Rhino file as an OBJ. Bam, Blender file viewer. Let's go to desktop, render engine test, OBJ export. There's our OBJ, there's our MTL file, import. Let's see how big this one imports. Takes a while. Okay, so I can see here that it's actually imported. So here we have it, our little character. There are certain areas that are welded. Now we can see it quite clearly. And also the whole mesh is joined up into one, right? So it imported as one single mesh containing 4 elements. Separate by material. Let's try doing it that way. By material, hit tab again. Let's see what we're dealing with now. Perfect. 4 simple objects. So now, and also those 4 simple objects already have a material attached to them. You can see them. You can see the materials here that are attached right now. That is, or rather here. So that is great. That means we will be able to work with those. So Eevee. Let's change this to rendered view. You can do that by clicking here. This is how Eevee looks like. And it looks like this because I think the only lighting that it has is from the exterior, from the atmosphere. So we're going to go and see where is that background color. Background color, there we go, background color, black. Okay, no color whatsoever. Let's create some lights. Shift A, light, and we will use an area light right here. That is upside down, so we either click RX 180, or we can just click here for the gumball, or whatever it's called, a widget I guess, and we just rotate it like so. But I prefer the fast one, RX 180. At this point, I feel like Eevee needs a little bit of a boost in quality because the shadows are a bit weird. I think I just crashed it. Oh no. Oh no. No. Okay, we're back. I'm not going to mess with cycles anymore for a bit. We're sticking to Eevee. So I did one more. As I was rebuilding this model, I did one more light. that is constrained to the helmet center point, but don't worry about that. And now I'm tick marking these contact shadows tick mark, which, well, you guessed it, gives me contact shadows. Is there a way, an easy way of how I can show them to you? So this is with, this is without. With, without. I guess you get the idea, right? Emissive materials, right? So this needs to emit light. Let's go into material settings, and here under emission, I guess we need to change the type. No, or there is probably emission here. We ramp it up to white, and then emission strength is right here, and we can increase it. By how much, you ask? I don't know. For that, I guess we can use bloom as like our indicator of stuff, of how intense the emission is. And this seems to be very intense, right? So we can tone it down just a tiny bit. There's also, you can also go to the shading menu and work with the materials here in the shading menu. Mapping, there we go. This one. So now with mapping, I think we can, is it possible to change the scale? Yes, yes it is. Okay, so that means if I do 5 by 5 by 5 here, it's gonna be much more, much denser, right? It's still too strong, so I'm going to decrease the strength just a tiny bit. And now we have a pretty nice look to it. So, more importantly, the shadows. The shadows are much more important because this doesn't, I don't like it. So here we do have shadows and we have our cube size and cascade size. So let's try to make it the highest precision possible. Is it really not the polygons, honestly? Because we're using the best shadow options that we possibly can. Subdivide. It was the polygons together with the shadows. That's interesting. Either way, now it's better. Now it's much better. Okay, so this is what we have so far. So one, well, let's continue changing the settings. So depth of field, we will do that later. Subsurface scattering. Here you can change the jitter threshold, which I have no idea what it does, but basically for samples, bigger number equals better preview. So let's double the samples and just call it a day. Then screen space reflections, you can see here in the bottom of the helmet. Once I turn them on, the helmet actually reflects surrounding stuff. That's how it works. Easy. Yeah, we're getting close to what I would call done. This is gonna be our camera angle. Depth of field. For this we need to create a camera, right? So let's create one. View. There is a way of how to create a camera from view. I remember that. Then we select the camera and we press Ctrl Alt Numpad 0 and it becomes our view, right? So it inherits our view and it gets repositioned to our view. Very intuitive. Great. And now we need to actually be able to move it and not move out of it, which I also don't know how to do. I guess just G, yeah, just G helps. Maybe I should just create another view so that it's easier for us to navigate around. So the sharpness of the shadow, that shadow I enjoy. I think that's fine. And this one can just be a straight up spotlight, but it's a little bit too intense. So let's do 1000 instead. And I think that's it. Now for the render, I'm going to say 256. For the viewport, 64 is fine. Then we just render it out, right? So first I'll save it. I learned my lesson. there needs to be a button somewhere, right? Render image. Is it done? It's a little bit too high. Also, what's up with that? That needs some love, some fixing. Besides that, it's kind of good-ish. There's already a normal map attached to this. Why is it not working? Hello? You should be working. Linear, non-color, tangent space. Is this the correct one? This is the only one that we have. And then for vector, and now it's a little bit more bumpy. So let's do 0.5, like half. Go back to our layout. And this actually starts looking a little bit better. This can stay smooth and silky. Let's render it again. I think we can call this success. For Eevee, this is pretty good. A brand new day. And one last render engine to test, which is going to be Blender's cycles. So since we already did the whole scene in Eevee, transitioning to cycles is not going to be that difficult. You can see here on my screen that I have chosen to use GPU compute rather than CPU, just because my graphics card is faster. And the way I did it was I first had to choose what kind of a GPU compute mode am I going to use. So under preferences, under system, there's either none, either CUDA cores, optics, or OpenCL. So since I'm using an RTX card, I went for optics because I think it benefits from RTX. Right, so let's see how it looks like actually. If I go and change the viewport shading, this is the preview. I think that looks pretty nice. I think that looks pretty cool. And there aren't that many things that I want to change here. I guess one of the most important ones is the fabric. I want to mess around with the fabric a little bit, and of course the translucency of the skin. That one I also want to change. But besides that, the lighting and so on, I think all of those are fine and can stay. So it seems like the normal map is being ignored for this particular material. Let's investigate it further. Okay, so there seems to be a thread on the internet that it's not just me who's having these problems with the normal maps, it's other people as well. So I will not even try making it work. I'm just going to straight up get rid of that, and we'll see if we can achieve something else with a different kind of technique. So let's see if displacement will work. All right, so after a little bit of Googling, this is how it looks like right now. Sure, I guess. We're just taking in a texture, and we are running it through a color ramp so that we can change the contrast of the texture, and we're using it as a height for the displacement. And to control the height, the actual height in meters or whatever this is, we use a value scroll or a value slider, I guess. So this is with 0, and as I'm increasing it, you know, this becomes bumpy. And I of course can also change the scale of the thing as well here, 0.2. So it's bigger, or make it smaller by changing it here. So for the skin, I think the subsurface scattering color is, or intensity is a little bit too low or too high, I don't know. So this is, yeah, okay, so this is fully transparent, and this is fully opaque. Okay, so we had 0.2. I guess we can just do 0.1. There we go. Okay, so this is how it looks like now. Hopefully it's going to be the final adjustment, because I'm getting tired. Oh, it's not. I will still need to add a little bit of a bump map for the body itself, but that's gonna be fast. So if I zoom in now, this is how the material looks like. I mean this one. I think that's reasonable. I mean, the mapping is bad, but the material itself is fine as long as you look at it from afar. The most important thing to nail is the scale of the bump map itself, or displacement map itself. I guess you can call it a bump map because it's not actually changing the vertices of the mesh. And I think the scale is almost correct. Yeah, and you get the nice little doodads there. Okay, so this is our render that we'll be using. Or angle, sorry, render angle. So now, does anyone remember how to align the camera with the view? Control Alt numpad 0. It's like I was born for this. Yeah. Okay. So that's done. Let's double everything. Because that's how you would do it, right? You would just keep doubling everything until you get like a higher quality render. Or your computer crashes. Let's try actually rendering it out here. I don't know how. I guess we still need to press this, right? And then it will get sent to the render. Anyway, it seems to be doing its thing, so I'm going to leave it and we'll investigate once it's done. So one thing led to another, and now we're rendering at 6,000 samples and we're rendering at 4K resolution. But finally it's done, and also it's nighttime again. You can see here the noise is still there, but I actually like the noise. Like the bump map is a little bit funky, but all in all, I think this is kind of a pretty decent render. And you can even see the bloom of this light. Usually you don't get that, but in our case, let me jump in here. There we go. In our case, I'm using a compositing node here where I'm adding the glare. So without the glare, it just looks like that. But with the glare, you give it a little bit of a additional shine, and you can kind of control the intensity of the glare right here. So this is like a After Effects post-processing thing, which I think is absolutely fine to have, you know, one more extra step after you've rendered it out. Either way, this is how it looks like. I'm going to save it, and then we'll do the final, not necessarily a comparison, but just a walkthrough of what we have. So let me just save it real quick. And there we go. So these are all of the renders that we have created for this video, and I'll just quickly go through them. So Twinmotion, this is the denoised version. The quality of the render itself, well, you can definitely tell that it's an like a render engine that's used for architecture. So the quality is, you know, not up to par with V-Ray or with Cycles, but I would argue that it's still pretty damn good, considering that we were not rendering a building, right? So that's Twinmotion. Then we have V-Ray, right? So I know how to use V-Ray, and I'm not gonna talk any more about it, but this is V-Ray. Then we have Blender. Honestly, really good. Like with Blender, the problem is the user experience, right? The quality that Cycles can achieve is really high, really high. The problem is getting there. So that's the usability on Blender side is, I would say, pretty bad, but the program itself is amazing, and just having it be free is wonderful. Said that, Blender Eevee, I mean, Blender Eevee needs to be compared to Twinmotion because they're kind of similar in that sense. So my thoughts are, if I were to go for a real-time rendering engine, I would go for Twinmotion for sure. Right, this is now my favorite real-time rendering engine by far. So Twinmotion gives a big thumbs up for me in terms of first-time usability and friendliness to the first-time user. Eevee said that still has the same problems as Cycles have, Blender being a clunky mess. But the output is again pretty nice. I mean, I didn't have any tragic issues. I had like 5 crashes, but besides that, seems to work. Keyshot. Just no. I mean, if they insist on putting this kind of watermark, I can't evaluate it, because I don't know the final output. Like, this is the final output that I have to show you, and it's literally a print screen. So that's a strong no from me. All in all, I think this was a success, because I found out that I will be using Twinmotion, and I still have a few programs out there that are with a question mark. And I will be continuing this video series with an actual architectural project. But the way I'm going to do them is we're going to do series of live streams, where I'll do a live stream about a single program. So for each program, we'll do a live stream, and during that live stream, I will construct a full architectural project through the selected programs. That's gonna take a while, but just so that you don't miss it, get subscribed. Yeah. Hope you enjoyed this one. I'll see you in the next one. Later.